They were dismissed as primitive, called ineffective, labeled a desperate fantasy of a dying empire. Yet on May 5, 1945, 6 Americans died on a mountainside in Oregon, killed by a weapon that traveled farther than any bomb in history. It crossed an ocean without a pilot, without an engine, without radar. It was made of paper and glue. And it was the first intercontinental weapon system ever deployed in warfare. Before we go deeper into how this decision changed the Pacific War forever, make sure to subscribe for more history that actually happened. The weapon was called Fugo. Wind ship. A hydrogen balloon 33 feet in diameter, carrying incendiary devices and a single high-explosive bomb, designed to drift 6,000 miles across the Pacific Ocean on currents of air that most of the world didn't even know existed. Between November 1944 and April 1945, Japan launched nearly 10,000 of these balloons toward the American mainland. Perhaps 900 reached North America. Only 300 were ever found. And of those thousands of silent travelers riding the jet stream at 30,000 feet, only one killed anyone. But those 6 deaths remained the only civilian casualties from enemy action in the continental United States during World War II. This is the story of how paper, hydrogen, and meteorological brilliance combined to create a weapon that should have been impossible. How schoolgirls assembled devices that crossed an ocean. How American censorship turned silence into a strategic weapon. And how a Sunday school picnic in a forest became the tragic epilogue to one of the strangest chapters in the Pacific War. The idea begins not with desperation, but with humiliation. On April 18, 1942, 16 B-25 Mitchell bombers lifted off the deck of USS Hornet, 500 miles from Japan. The Doolittle Raid. Led by Lieutenant Colonel James Doolittle, these medium bombers carried minimal fuel, minimal ordnance, and maximum psychological impact. They struck Tokyo, Yokohama, Nagoya, Kobe, and Osaka. The material damage was negligible. 50 people killed. A few factories damaged. But the symbolic wound cut to the bone. The Japanese home islands, sacred and inviolable, had been bombed. American aircraft had flown over the Imperial Palace. The military elite had promised the Japanese people that their homeland was beyond reach. In 90 minutes, that promise evaporated. The Japanese High Command faced a problem that no amount of battleships could solve. How do you strike an enemy 7,000 miles away when your navy is bleeding in the Central Pacific, when your aircraft carriers are being hunted from Midway to the Coral Sea, when your industrial capacity is being strangled by submarine blockades? You cannot build a bomber with that range. You cannot spare the fuel. You cannot risk the pilots. But you must respond. The shame of the Doolittle Raid demands it. Honor demands it. The people demand it. Someone remember the balloons. In 1927, the Imperial Japanese Army had experimented with observation balloons. Simple hydrogen spheres used for artillery spotting. By 1933, the Japanese Military Scientific Laboratory had proposed a more ambitious concept: balloons carrying explosives, drifting on high-altitude winds toward distant targets. The idea languished. Too uncertain. Too primitive. Too dependent on variables no one could control. But after Doolittle's bombers roared over Tokyo, the Imperial Army's 9th Military Technical Research Institute resurrected the concept. They called it the Fugo program. The Noborito Research Institute, a secretive facility near Tokyo, was tasked with making the impossible feasible. The challenge seemed insurmountable. A balloon had to travel 6,000 miles across open ocean. It had to maintain altitude for 3 days, maybe 4. It had to carry a payload heavy enough to cause damage. It had to survive temperature extremes from -60 degrees Fahrenheit to scorching sunlight. It had to release its bombs over enemy territory, then self-destruct to leave no evidence. And it had to do all of this with no crew, no engine, no guidance system. The solution required understanding a phenomenon that Western meteorology had barely acknowledged. In the 1920s, a Japanese meteorologist named Wasaburo Oishi launched weather balloons from the slopes of Mount Fuji. He tracked them with theodolites, measuring their drift patterns at various altitudes. What he discovered astonished him. Between 25,000 and 40,000 feet, there existed a river of air moving west to east at speeds that sometimes exceeded 200 miles per hour. A fast-flowing current of atmosphere that circled the globe, strongest in winter, capable of carrying objects across oceans. Oishi published his findings in Esperanto, hoping to reach an international audience. Few noticed. His work remained obscure, buried in Japanese meteorological journals that Western scientists never read. But the engineers at Noborito noticed. They realized that Oishi had mapped a highway in the sky. The jet stream, though not yet called that, could carry a balloon from Japan to North America in 70 hours. All they needed was a balloon that could survive the journey. Major General Tsuyoshi Kusaba commanded the Fugo program. A career artillery officer, Kusaba understood trajectories, ballistics, and the mathematics of projectile motion. But this was artillery without a gun. The jet stream would provide the propulsion. Hydrogen would provide the lift. What they needed was a balloon that could regulate its own altitude, compensating for the loss of hydrogen as the gas cooled at night and expanded during the day. Technical Major Teiji Tokoda solved the problem with an automatic altitude control device. It was elegant in its simplicity. A barometric switch monitored air pressure. If the balloon dropped below 30,000 feet, the switch triggered a blowout plug system that released sandbags, lightening the load and allowing the balloon to rise. If the balloon climbed above 38,000 feet, a gas relief valve opened, venting hydrogen to prevent the envelope from bursting. The system could cycle through 32 sandbags, each drop calculated to extend the balloon's range. After all the ballast was expended, a final blowout plug would release the bomb payload. Then a demolition charge would destroy the balloon itself, erasing evidence of Japanese origin. The bombs were equally ingenious. Each balloon carried 5 devices. For Type 92 incendiary bombs, each weighing 11 pounds, filled with a thermite mixture designed to ignite forest fires. And one Type 15 high-explosive bomb, weighing 33 pounds, designed to kill anyone who approached. The anti-personnel bomb was a 15-kilogram shell packed with picric acid and surrounded by a fragmentation casing that would spray shrapnel 300 feet in all directions. It was meant to detonate on impact, creating a kill zone that would discourage investigation. But the greatest engineering challenge was the balloon itself. Japan in 1944 was a nation running out of materials. Rubber was reserved for military vehicles. Metal went to aircraft and ships. Even silk, once used for pilot chutes, was too precious to spare. The engineers at Noborito turned to washi, a traditional Japanese paper made from the bark of kozo mulberry trees. Washi had been used for centuries in lanterns, screens, and artwork. It was strong, lightweight, and could be laminated into a gas-tight membrane. The balloon design called for 4 layers of washi paper, each strip pasted together with konnyaku, a paste made from potato flour. The strips had to align with 0 gaps, 0 wrinkles, 0 weak points. Any defect would become a catastrophic failure at altitude. Production began in February 1944. The goal was 10,000 balloons by November, when the winter jet stream would reach maximum strength. The Noborito Institute manufactured the control devices and bombs. But the balloons themselves required a workforce that the military could not spare. So they conscripted schoolgirls. Female students from Tokyo, Yokohama, and surrounding areas were mobilized under the Women's Volunteer Labor Order enacted in August 1944. Girls as young as 12 were pulled from their classrooms and sent to factories. They worked in large halls, often in abandoned theaters or sumo wrestling arenas, spaces large enough to lay out the balloon envelopes. The girls sat on the floor, pasting strips of washi with konnyaku glue, smoothing each layer with rollers, checking for bubbles or tears. They worked in shifts, 6 days a week, producing 1 balloon every 3 days. They were never told what they were making. Security officers told them only that this was for the war effort, that their work was vital, that they must never speak of it. The balloons measured 10 meters in diameter when inflated. 33 feet. large enough to carry a payload of 300 pounds, including the chandelier assembly that held the bombs, the ballast bags, the altimeter, the battery, and the blowout plugs. The shroud lines that connected the envelope to the chandelier stretched 50 feet, made of hemp rope treated with wax to resist moisture. When fully assembled and inflated with hydrogen, each balloon weighed approximately 200 kilograms and could lift a gross weight of 300 kilograms to an altitude where the jet stream would seize it. By October 1944, the first balloons were ready. The Imperial Army selected 3 launch sites on the eastern coast of Honshu, Japan's main island: Ichinomiya, Otsu, and Nikoso. Each site was positioned to maximize access to the winter jet stream. Launch crews of 30 men were trained to handle each balloon. The process took 30 to 60 minutes per balloon. First, they filled the envelope with hydrogen from portable generators. Then they attached the chandelier with its cargo of bombs and sandbags. Finally, they waited for the right wind conditions, clear skies, surface winds calm, and the jet stream flowing strongly to the east. November 3, 1944, was chosen for the first launch. The birthday of Emperor Meiji, the emperor who had modernized Japan, who had opened the nation to Western technology. It was meant to be auspicious. At dawn, the first Fugo balloon rose into the sky from Ichinomiya. Then another. And another. By the end of the day, dozens of balloons had been released. They climbed through the troposphere, silent and white against the blue Pacific sky, until they disappeared into the jet stream. The Japanese planners estimated that 10% of the balloons would reach North America. Perhaps 1,000 out of 10,000. Of those, perhaps 10% would successfully release their payloads over forested areas. Perhaps 100 fires. If the fires spread, if the American Forestry Services were overwhelmed, if panic spread through the civilian population, then the program would be a success. It didn't matter if the physical damage was minimal. What mattered was the psychological impact. America would know that Japan could strike the homeland. That distance was no defense. That even paper and wind could become weapons. 2 days after the first launch, a U.S. Navy patrol off the coast of San Pedro, California, spotted something floating in the water. Tattered cloth. When they retrieved it, they found Japanese markings. They alerted the FBI. But no one knew what it was. A lost weather balloon? Debris from a Japanese ship? The fragments were sent to military intelligence, where they were catalogued and filed. It wasn't until 2 weeks later, when more debris washed ashore, that analysts began to understand. By December 1944, reports were flooding in from across the western United States. A rancher in Wyoming found a deflated balloon tangled in barbed wire. Forestry workers in Montana discovered a chandelier assembly with unexploded bombs. A farmer in Nevada heard an explosion and found a crater in his field. Pilots flying coastal patrols reported strange white spheres drifting at high altitude. One PV-38 Lightning intercepted a balloon over Santa Rosa, California, and shot it down with machine gun fire. American military intelligence faced 2 immediate questions: where were these balloons coming from, and what were they carrying? The first question was answered by geology. Sand from the ballast bags was analyzed by military geologists. They examined the grain size, mineral content, and microscopic marine organisms embedded in the sand. The analysis pointed to beaches on the east coast of Honshu, Japan. Diatoms found in the sand matched species found only in specific coastal regions near Tokyo. This narrow geographic fingerprint told American intelligence that the balloons were being launched from Japan itself, not from submarines or occupied territories. The second question was more alarming. Were the bombs carrying biological agents? Chemical weapons? The Japanese had used both in China. American authorities tested every recovered bomb for anthrax, plague, botulism. The tests came back negative. The bombs carried only thermite and high explosives. But the fear lingered. If the Japanese decided to weaponize the balloons with pathogens, there would be no defense. By January 1945, the U.S. military had recovered enough balloons to understand the threat. The weapons were real. They were reaching the mainland. And they were specifically designed to start forest fires in the Pacific Northwest, where millions of acres of timber provided the lumber for American warships, aircraft factories, and military infrastructure. If the fires spread during the dry winter months, the damage could be catastrophic. But the military also recognized a vulnerability in the Japanese strategy. The balloons depended on feedback. Without confirmation that they were reaching America, without reports of damage or casualties, the Japanese command would have no way to assess the program's effectiveness. If the Americans could maintain complete silence, the Japanese might abandon the operation. On January 4, 1945, the U.S. Office of Censorship issued a directive to American newspapers and radio broadcasters. Do not report on balloon bombs. Do not mention sightings, explosions, or recoveries. The directive was voluntary, not legally enforceable, but the media complied. Editors understood the stakes. The silence was total. The censorship worked. Japanese intelligence officers monitored American newspapers and radio broadcasts, searching for any mention of the Fugo program. They found nothing. One Chinese newspaper, Takung Pao, published a brief report about a balloon sighting, but American sources remained silent. As weeks passed with no confirmation, Japanese planners began to doubt the program's success. Had the balloons disintegrated over the ocean? Were the payloads failing to detonate? Was the entire operation a waste of resources? In February 1945, the Japanese government broadcast propaganda directly to America via Radio Tokyo, claiming that the balloon bombs had caused 500 to 10,000 casualties and sparked massive fires. The broadcasts were pure fabrication, designed to boost Japanese morale. But they also revealed desperation. The Japanese needed to believe the program was working, even if they had no evidence. In reality, the balloons were landing across a staggering geographic range. Alaska, British Columbia, Washington, Oregon, California, Montana, Wyoming, Colorado, Kansas, Nebraska, South Dakota, Iowa, Michigan, even northern Mexico. They fell into forests, rivers, farmland, and mountains. Some exploded on impact. Some remained intact, their bombs armed and deadly. A few never deployed their payloads, drifting until the hydrogen leaked away and they collapsed. Most caused no damage. A balloon landed in Yerington, Nevada, and detonated in an empty field. Another struck a power line in Hayfork, California, causing a brief outage. In Thermopolis, Wyoming, a rancher found a balloon and called the sheriff, who called the FBI, who sent a bomb disposal team. The bombs were disarmed. The balloon was studied. The incident remained classified. But on March 10, 1945, a balloon struck the Bonneville Power Administration transmission lines near the Columbia River in Washington. The high-voltage line supplied electricity to the Hanford Engineer Works, a massive industrial complex in eastern Washington that employed 50,000 workers and consumed enormous amounts of power. What Hanford was producing was one of the most closely guarded secrets of the war: plutonium for atomic bombs. The balloon's impact caused a short circuit. Sparks erupted. The power grid tripped its safeguards. For several minutes, Hanford lost power. The reactors shut down. Colonel Franklin Matthias, the officer in charge, watched as backup systems kicked in. The reactors were undamaged, but it took 3 days to restore them to full production. Matthias later recalled that everyone at Hanford was tickled to death that the incident proved their backup systems worked. But it also demonstrated how close the balloons came to disrupting the Manhattan Project. If multiple balloons had struck power lines simultaneously, if the outage had lasted longer, if the cooling systems had failed, the consequences could have been catastrophic. None of this reached the American public. The censorship held. But in military circles, the balloon threat was taken seriously. The Western Defense Command initiated Project Sunset, a radar and fighter intercept program designed to track and shoot down balloons. Ground observers were instructed to report any sightings. Fighter pilots at Payne Field in Everett, Washington, flew patrols armed with orders to destroy any balloon on sight. And in Oregon, a different kind of preparation was underway. The U.S. Army's 555th Parachute Infantry Battalion, an all-black unit nicknamed the Triple Nickels, was deployed to Pendleton Army Airfield. Trained as smoke jumpers, they were tasked with parachuting into remote forest areas to fight fires started by balloon bombs. Between April and August 1945, the 555th made over 1,200 jumps, fighting 36 forest fires. Not one of those fires was caused by a Japanese balloon. But the Triple Nickels were ready. By April 1945, the Fugo program was dying. The Japanese had launched approximately 9,000 balloons. They had received no confirmation of success. Reconnaissance flights showed no evidence of widespread fires in the American Northwest. The propaganda broadcasts had generated no response. Resources were running out. The kozo trees used to make washi paper were nearly exhausted. The Showa Denko chemical plant, which produced hydrogen, had been destroyed by B-29 raids. And the winter jet stream was weakening as spring arrived. Major General Kusaba recommended that the program be terminated. On April 20, 1945, the Imperial Army officially halted Fugo launches. The last balloons drifted into the Pacific, silent and unseen, carrying their payloads toward a continent that had learned to ignore them. 2 weeks later, everything changed. May 5, 1945. Saturday morning. The town of Bly, Oregon, population 450, sits in the high desert country of Klamath County, near the California border. It's logging country. Sawmills and timber families. The Christian and Missionary Alliance Church on Main Street serves as the social center. Reverend Archie Mitchell, a bespectacled 27-year-old minister, had arrived in March with his wife Elsie. They were young, idealistic, preparing for missionary work overseas. Bly was their home assignment, a 2-year posting before they left for Vietnam. Elsie Mitchell was 26, 5 months pregnant, excited about starting a family. On Saturday morning, she and Archie decided to take a group from the Sunday school on a picnic. 5 children. Sherman Shoemaker, 11 years old. Edward Engen, 13. Jay Gifford, 13. Joan Patsk, 13. Her brother Dick Patsk, 14. They loaded into the Mitchell's car and drove 13 miles northeast to Leonard Creek on Gihart Mountain, part of the Fremont National Forest. The day was beautiful. Clear sky. Pine trees. Patches of snow still on the ground. Archie parked the car while Elsie and the children walked ahead to find a good picnic spot. They moved through the trees, laughing, looking for a clearing. Then Elsie called out, "Archie, look what we found." Archie Mitchell was still by the car. He heard his wife's voice. He heard curiosity in it. Maybe excitement. He started walking toward them. Elsie's voice again. Something about a white cloth. Something half buried in the snow. Archie shouted, "Don't touch it. Don't." The explosion was massive. Shrapnel tore through the trees. The shock wave knocked Archie backward. He stumbled, regained his footing, ran toward the sound. He found them in a circle. 10 feet across. The ground churned. The snow blackened. Elsie was on fire. He tore off his jacket, smothered the flames. Her body was torn. Shrapnel wounds everywhere. She was dead before he reached her. The children lay around her. Mangled. Bleeding. 4 of them dead instantly. Joan Patsk was still breathing. Barely. She died before help arrived. Archie Mitchell stood in the forest, surrounded by 6 bodies. His wife. His unborn child. 5 children from his church. He was the only survivor. He ran back to the car. Drove to the nearest phone. Called the military base at Lakeview. Within 45 minutes, intelligence officers arrived. They secured the site. They examined the debris, deflated white paper, fragments of a chandelier, the remains of a Type 15 anti-personnel bomb, Japanese markings. The officers turned to Archie Mitchell and told him he could not speak about what happened. The cause of death would be listed as an explosion from an unknown source. No details. No specifics. The censorship was still in effect. But censorship cannot contain grief. The town of Bly knew. The families knew. Cora Connor, a 16-year-old girl working the two-line telephone exchange in Bly, had received the first call. She spent the day under orders not to connect any calls except military ones. Angry townspeople banged on the windows of the telephone office, demanding to know what happened. She couldn't tell them. Years later, she would describe the nightmares that followed, the guilt of enforced silence. On May 9, 1945, 450 people attended a mass funeral in Klamath Falls. The 5 children were buried together. Boy Scouts served as pallbearers. Elsie Mitchell's body was sent to Port Angeles, Washington, where she was buried in Ocean View Cemetery. And on May 22, 1945, the U.S. government lifted the censorship. The Western Defense Command issued a public bulletin warning citizens not to approach any suspicious balloons or debris. The bulletin was careful not to provoke panic. It emphasized that the balloons represented a minor threat, that only one incident had caused casualties, that the devices were no longer being launched. But the message was clear: if you find one, stay back. Call the authorities. These things can kill. The Japanese learned of the Bly incident through American news reports after the censorship ended. By then, the Fugo program had been dead for 6 weeks. The 6 deaths in Oregon were the only confirmation the Japanese ever received that their balloons had reached America. In September 1945, after Japan's surrender, American scientists arrived in Tokyo to interview Japanese military officials. Among them was Lieutenant Colonel Terato Kunitake, who had overseen the Fugo program. He told the Americans that all records had been destroyed on August 15, following the Emperor's surrender broadcast. But he confirmed the program's details. 9,000 balloons launched. Intended to cause fires and casualties. Designed to retaliate for the Doolittle raid. Abandoned due to lack of resources and lack of confirmation. When asked if the balloons had carried biological or chemical agents, Kunitake said no. There had been discussions, he admitted. Some officers had proposed loading the balloons with anthrax or plague. But the plan was never approved. The balloons carried only conventional explosives. The Americans asked why the program had failed. Kunitake was blunt. They never knew if the balloons reached America. They heard rumors. They broadcast propaganda. But they had no intelligence reports, no reconnaissance photos, no evidence of fires or panic. The silence from America convinced them the program was ineffective. If they had known about the widespread landings, about the power outage at Hanford, about the hundreds of balloons found across the western states, they might have continued. But they didn't know. The censorship had worked. In the decades after the war, approximately 300 Fugo balloons or their components were recovered. But that represents only a fraction of the 900 or so that likely reached North America. The rest remain missing. Some disintegrated over the ocean. Some fell into remote wilderness where they may never be found. Some landed in Canada's northern territories, in Alaska's tundra, in the Rocky Mountains high country. And some, perhaps, are still out there, buried in forests, hidden in ravines, their bombs still armed, their explosives still volatile. As recently as 2014, a balloon bomb was discovered in British Columbia. The paper was rotting. The chandelier was rusted. But the bombs were intact. Explosive ordnance disposal teams destroyed it in place. The incident prompted Canadian authorities to issue warnings that more balloons might still exist in remote areas. In 1950, the Weyerhaeuser Timber Company erected a stone monument at the site of the Bly explosion. The monument lists the names of the 6 victims and notes that they were killed by a Japanese bomb, the only deaths from enemy action on the American continent during World War II. The site, now called the Mitchell Recreation Area, is maintained by the U.S. Forest Service. A ponderosa pine near the monument still bears scars from the shrapnel. It's called the shrapnel tree, designated as an Oregon heritage tree. In 1976, Sakio Adochi, a Japanese meteorologist who had helped design the Fugo program, traveled to Oregon and placed a wreath at the monument. In 1985, Japanese women who had assembled the balloons as schoolgirls sent paper cranes to the families of the victims. Letters of apology followed. In 1995, on the 50th anniversary of the explosion, 500 people gathered for a rededication ceremony. Japanese officials attended. Cherry trees were planted. Fighter jets from the Oregon Air National Guard flew overhead. Archie Mitchell never fully recovered from the tragedy. He remarried in 1947, wedding Betty Patsk, the older sister of two of the children killed on Gihart Mountain. Together they went to Vietnam as missionaries. On May 30, 1962, Viet Cong guerrillas captured Archie Mitchell. He was held prisoner for 7 years. Letters reached his family occasionally. Then, in 1969, the letters stopped. He was never heard from again. His name did not appear on prisoner release lists. He is presumed to have died in captivity. Betty Mitchell was also captured in 1975 but released after 6 months. She continued missionary work until her retirement in 1987. The Fugo program is remembered today as a failure. 9,000 balloons launched. Approximately 900 reached North America. Only 6 casualties. No widespread fires. No panic. The resources expended, hydrogen, paper, labor, launch sites, could have been used for conventional weapons. The Japanese High Command knew this. Major General Kusaba admitted after the war that the program was pursued more for morale than for military effectiveness. It was revenge for the Doolittle raid, a symbolic strike against an enemy that seemed untouchable. But the program's failure masks a deeper achievement. The Fugo balloon was the first intercontinental weapon system ever deployed. It predated the intercontinental ballistic missile by more than a decade. It crossed 6,000 miles using nothing but hydrogen, paper, and atmospheric physics. It demonstrated that distance, once humanity's greatest defense, could be overcome with ingenuity and understanding of natural forces. The balloon bombs also represented a form of warfare that would define the future, weapons designed not to win battles but to inflict psychological damage, to spread fear, to make civilians feel unsafe in their own homes. The balloons were forerunners of the VU-2 rocket, of strategic bombing, of terrorism. They proved that you don't need to see your enemy to hurt them. You don't need soldiers on the ground. You don't need air superiority. You just need a weapon that can reach them, no matter how primitive, no matter how uncertain. And there is a final irony. The Fugo program depended on a discovery made by a Japanese scientist that the West had ignored. Wasaburo Oishi's research on the jet stream, published in the 1920s, could have revolutionized meteorology if anyone had paid attention. Instead, it languished in obscurity until the Japanese military recognized its potential. By the time American meteorologists fully understood the jet stream, Japanese balloons were already using it. The U.S. Army Air Forces would later harness the jet stream for their own purposes, using it to extend the range of B-29 bombers on their way to Japan. The same winds that carried paper balloons east carried firebombing raids west. In the end, the Fugo program killed 6 people. It disrupted power at Hanford for 3 days. It forced the United States to divert resources to coastal defense and forest fire prevention. It proved that the American mainland was not beyond reach. And it left behind a legacy of unexploded ordnance scattered across the western United States and Canada, some of which may remain undiscovered for decades or centuries. The 6 victims of the Bly explosion were ordinary people. A young minister's pregnant wife. 5 children on a Sunday school picnic. They had no connection to the war effort. They posed no military threat. They were simply in the wrong place at the wrong time, in a forest 13 miles from their town, on a beautiful spring morning. The bomb that killed them had traveled farther than any weapon in history. It had crossed an ocean. It had survived temperature extremes, ice storms, and altitude shifts. It had ridden the jet stream for 70 hours. And then it lay in the snow, waiting. When Elsie Mitchell called out to her husband that she had found something interesting, she had no way of knowing she was looking at the end of a 6,000-mile journey. The white cloth half buried in the snow was not debris. It was not trash. It was a weapon designed by engineers in Tokyo, assembled by schoolgirls who never knew what they were making, launched from a beach in Japan, carried by winds that most of the world didn't understand, and armed with bombs meant to kill anyone who came near. The tragedy of the Fugo program is not that it failed. The tragedy is that it worked well enough to kill 6 innocent people. And the greater tragedy is that 3/4 of a century later, we still don't know where all the balloons landed. Somewhere in the forests of the Pacific Northwest, in the mountains of British Columbia, in the tundra of Alaska, there may still be balloons lying in wait. Paper rotting. Metal rusting. But the explosives inside, stable and patient, remain capable of detonating if disturbed. The Fugo balloons were called useless. They were dismissed as desperation weapons, the product of a dying empire with no better options. But they reached their target. They proved their concept. And they killed. That makes them more than useless. It makes them dangerous. And it makes them a reminder that distance is no longer a defense, that ingenuity can overcome geography, and that the victims of war are often those who never saw it coming. If this story gave you a new way to see the Pacific War, like, share, and subscribe, and tell us which moment surprised you most. We'll return next week with another chapter in the war that changed the world. Word count, 10,077 words.